In a moment on Coast to Coast AM. Cliff, let's go through these 7 that you had pointed out to us. We'll digest each one here. It'll probably take us the entire hour, but they'll be well worth it. Environmental matters here, modification, perhaps weather manipulation as well.
Sure, George. Thank you. We talked about contrails and how they're physically composed, and we talked about clouds and what are the requirements for clouds to form. If you now introduce a third entity, that of the aerosol, it changes the dynamics of what's happening in a big way in the sky. Remember that contrails require nothing except for moisture, basically, to freeze in a cold environment. Clouds require moisture and particles. Now, what if you were to introduce an extremely small particle, which is what they need to be for clouds, they call them nuclei. What if you were to introduce a very small particle, and that particle had the ability and capacity to absorb moisture at very low humidity levels? What would happen?
If you would do that at very low humidity levels?
Absolutely. The operations are conducted essentially at flight altitude, roughly 35 to 40,000 feet. There's people will say exceptions, but generally, high altitude in terms of aviation traffic is taking place, and the moisture at that level is generally quite low. This is why contrails form fine there.
Okay.
You do not need much moisture up there. But if you were to introduce a salt that can absorb moisture at very low levels, and there are some, and strontium chloride is the one that I have documented that will absorb moisture at roughly 30% humidity, okay? This changes everything because where clouds require moisture levels of roughly humidity levels of roughly 70% or greater to form, if you introduce a water-loving nuclei or small particle in a low moisture environment, it can create let's say a phenomenon which we are now confusing as this grand mix that there's really no difference anymore between contrails and clouds. We create these things that we don't really know what they are, but we start conveniently calling them clouds, even though they're developing at the level of where cirrus clouds form, which are thin, wispy clouds. But suddenly we have an entire layer across the sky at 35,000 feet. You're changing the physics of the atmosphere in a way that is creating a new entity.
Maybe that's why it's so turbulent out there when we're in a plane.
Well, another thing, in terms of environmental modification and control, what happens then? Okay, you are affecting the moisture levels in a big way. You're attracting moisture, and essentially you're locking up the moisture in the atmosphere. And my conclusion, one conclusion would be that this is a quite feasible means of harnessing the energy of storm systems. I've done quite a bit of work to try and determine when these operations are actually taking place, and there's an interesting body of work involving ionization and humidity. But if you look at that work, the conclusion is reached that the most likely times that the operations are occurring in any given area are moments or periods of what you would call local low relative humidity. And the word local is real important because it means relative to what was happening before and after. It doesn't mean local and low in an absolute sense necessarily, okay? And it's quite an interesting phenomenon, but down literally to the period of a matter of a few hours, over and over and over. I did this study for roughly a month and a half, measured ionization levels and humidity levels, and looked at that data very carefully. And this is a pattern that is emerging from that it's a very strategic time in which they are coming in. And it's not, as people claim, during periods of high humidity. If you look at the counter-argument here, they'll say, hey, this is just normal and fine as could be. These things are going to happen when your humidity is high. These operations are not taking place when the humidity is high. They are taking place most often, what I see, immediately before and prior to entering humidity.
All right, then I assume they also then create rain with these false clouds. What's the purpose?
Well,
why would they do
that? Actually, I believe it's destroying the rain, George. It locks up that moisture.
All right.
It does not. We are losing our rainfall from this.
Okay.
You are locking up this moisture, and I believe harnessing the energy of that storm to use in other ways, which is where we get into the electromagnetic aspects, because these materials, as I mentioned, have the ability to be ionized or become charged through sunlight. and you start to change the dynamics of everything going on there. But sticking to the issue of environmental modification, one is that you expect the moisture patterns of the planet to be dramatically altered, and in general, you expect the moisture to be diminished. This is what you would expect. The second thing is that these materials, they're heating up the air. You know, there's a lot of airtime and press which has been given to the notion that these materials are somehow in there for our good, even though we're not supposed to know about them. They're somehow for our good, and it's some benevolent program to inhibit or mitigate global warming. The evidence does not support that thesis at all. From what I see, these materials are heating up. It's based on heat, specific heat of a material. These materials are being dispersed into the lower atmosphere. A lot of folks are citing a report by Teller saying that, hey, he laid this whole thing out, and then this is what you do, you dump this stuff in the air. If you look at Teller's report, he did not say putting this stuff in the lower atmosphere. He said at the very least, the lowest place you would put this stuff would be in the stratosphere, 18 miles above, not 6 and 7 miles above the Earth. He says that the stratosphere is not a favorable location to be doing this, and where you really want to be doing is out in low orbit, roughly 150 miles away above the Earth, or 400,000 miles. The guy is talking about putting this stuff in space because it heats up, and you want to draw the heat away from the Earth. You don't put this material into the lower atmosphere as it is and expect it to be curing global warming. As a matter of fact, the evidence says it is as exacerbating and aggravating global warming, if not a significant constituent and component of the global warming.
Could it be causing droughts in the region?
Absolutely. It's actually expected to be causing droughts. If you put a desiccating material into the upper atmosphere that draws that water and holds it in and becomes basically an electrically conductive environment, you're playing with your weather in a very big way. You expect the moisture patterns, you expect the heat patterns, and you expect the wind patterns to be dramatically altered as a result of introducing this material, hence the likely agenda, one of many, but the likely agenda of environmental modification and control, but not for the purpose of mitigating global warming by any sensible interpretation of the data that I can see, but in fact aggravating and exacerbating the problem, if not directly contributing to it.
Fascinating. Biological. What are they doing there?
All right. If you look at these samples, it started with those filaments that we spoke of. If you look at these samples, you start to see a very unusual entity exist in those samples. And anytime I do something, it's not once. It's usually not one time. It has to be repeated.
All right.
Okay? You had these filaments come in. There was a medical professional in this area that was looking at these materials at the same time I was. I did not know that at the time. I was putting my work under the microscope, offering what I could. I started out with a $30 toy microscope when I first did my work, offered what I could to people. I had an individual contact me and said, Clifford, I'm seeing some things you can't see. Come down here and take a look. This individual had some of these similar filaments, if not identical filaments, that I had in my sample. And in fact, his purpose for having me there was to have a second independent sample because he wanted to see if what was happening in his sample was happening in an independent sample. Because what he was seeing was some, let's say, quite sophisticated and advanced microscope equipment. He was seeing a biological component. Now, I'm going to say this outright because it's what he said. This was not my conclusion. This was his conclusion at the time. He said, my identification of this material is as a red blood cell. Now, that sort of blew my mind at that point, okay, because now you know if that's true, you're dealing with something really heavy here.
Absolutely.
All right? Because this is far beyond what anyone would expect. Now, at that point, I don't try to pass judgment right away. I try to get the data, and all I'm saying is this is what the person told me. We spent time under the microscope. What he needed was my sample to see if it had the same elements, components within it. The fact is it did, and that's what he was after, to find out if this was unique or one of a kind, or it could be corroborated with another sample. While I was there, I noticed something under the microscope that he had not seen that was even sort of more unusual, and that was a cluster development. Those photographs and all that work is posted on the site. The fact is that at that point, there was an initial discovery that said we're dealing apparently not with just with unusual fibers, but it looks like we may be dealing with a biological aspect to these materials as an added component.